In production, a Fabric network must be observable, auditable, protected, and recoverable. In this module, we'll look at monitoring, logs, backups, and disaster recovery across peers, orderers, applications, and infrastructure. So failures become managed events, not business-threatening surprises. So far, we've moved from Fabric architecture through chaincode, application integration, Kubernetes deployment, CI/CD, security, scaling, and high availability. Now we close the operations loop, keeping a production network observable, recoverable, and trustworthy before we move into governance and compliance. Fabric observability connects operational signals to business-critical blockchain behavior. Metrics, logs, traces, and events from peers, orderers, certificate authorities, chaincode, clients, and databases should be correlated, not reviewed in isolation. The goal is to spot patterns early: rising endorsement latency, stalled block height, failed validations, slow commits, or identity problems. Dashboards show current health, while alerts prompt action before degraded performance becomes an outage. A Fabric monitoring stack begins by treating every operational component as a metric source: peers, orderers, chaincode, Kubernetes infrastructure, databases, and certificate services. Prometheus typically pulls values from metrics endpoints using exporters and service discovery as workloads move. Grafana turns that data into live health views and longer-term trends. Alertmanager routes urgent signals, while retained history supports capacity planning, incident review, and SLA reporting. Transaction health is best understood as a life cycle, not a single metric. Start with endorsement. Rising latency or proposal failures often point to chaincode, peer, or policy issues. Next, watch ordering delay and submission rate for signs of congestion. During validation and commit, invalid codes, MVCC conflicts, and commit latency reveal consistency problems. Finally, compare event delivery, ledger height, and application success rates against business SLAs, so technical signals map to real outcomes. Healthy operations require more than checking whether a pod is running. For peers, watch availability, gossip, ledger height, state database access, and chaincode status. For orderers, monitor consensus membership, leader or follower behavior, block cutting, and cluster communication. Then validate the infrastructure underneath: CPU, memory, disk I/O, volume usage, file descriptors, and network latency. Kubernetes probes are useful, but tune them carefully. A brief spike should not trigger restarts that make the problem worse. Strong alerting starts with business impact. Not every signal deserves a page, so classify severity from informational through emergency. Make alerts actionable: peer down, orderer unavailable, ledger lag, disk exhaustion, expiring certificates, or high invalid transaction rates. Route each alert to the team that owns the service, whether platform, security, application, or consortium operations. Every alert should link to a runbook for triage, escalation, mitigation, recovery, and post-incident review. Logs are operational evidence, but only if they can be connected across components. Use structured fields such as timestamp, organization, channel, chaincode, transaction ID, severity, and correlation ID, so one event can be traced end-to-end. Collect logs from peers, orderers, CAs, chaincode, clients, Kubernetes, and databases into a central backend. From there, index, search, alert, and retain them according to policy, balancing detail with cost and sensitivity. A Fabric transaction is not just one log entry. It moves from the application through peers, chaincode, ordering, commit events, and often into enterprise systems. A correlation ID ties those steps together, while the Fabric transaction ID anchors the ledger operation. Capture who submitted it, which channel and chaincode were used, endorsement results, and emitted events. Audit trails extend that trace to administrative actions, supporting compliance, investigations, and accountability. Logs should support operations without becoming a data breach risk. Record identifiers that help diagnosis, such as transaction IDs, component names, error codes, and timestamps. Avoid raw passwords, tokens, private keys, personal data, and full payloads. Redact or tokenize sensitive fields before they leave the application boundary. Then protect the logs themselves with access control, encryption, retention rules, and tamper-evident storage, especially when they serve as audit evidence. A Fabric backup is only useful if it can rebuild the network, not just restore blocks. Protect the ledger, state databases, orderer data, snapshots, and persistent volumes. Just as importantly, preserve identities. MSP folders, certificates, CA records, CRLs, TLS material, and related configuration. Also capture channel artifacts, configuration history, anchor peer and orderer settings, chain code packages, lifecycle metadata, manifests, Helm charts, secrets references, and infrastructure code. If identity or configuration is missing, recovery is incomplete. Treat backups as a recovery workflow, not a storage task. First, define what must be protected. Peers, orderers, state databases, CA data, persistent volumes, and configuration repositories. Then capture backups and Fabric snapshots consistently. Verify them with checksums, encrypt them, and keep copies off-site. The most important step is rehearsal. Restore into a non-production environment, measure recovery time, document gaps, and feed those lessons back into the plan. Disaster recovery starts with two business promises. RPO defines how far back you can afford to lose data. RTO defines how long the network can be unavailable. Those targets vary by scenario. Losing one peer is different from a region outage, certificate compromise, corrupted state database, or operator mistake. The plan should map each failure to a recovery approach. Backups, replication, rebuild steps, key rotation, or failover. Above all, DR targets must match compliance obligations and business criticality. In Fabric, disaster recovery has two layers: regional resilience and consortium coordination. Each organization needs its own plan for peers, CAs, MSP material, databases, backups, and application endpoints. Shared actions, such as restoring ordering services, updating channel configuration, revoking certificates, and notifying members, require agreed governance. That is why runbooks matter. They turn a stressful outage into a rehearsed sequence for failover, failback, data restore, chain code redeployment, and post-incident review. The main message is simple. Deployment is only the beginning. Enterprise Fabric needs observability, complete backups, tested recovery plans, and coordinated incident response. These practices protect continuity and auditability. They also prepare us for the next module, where we connect operations to governance, identity, compliance, privacy, and risk.